Good evening. In previous session, we have seen the concept of how to create a thread in three ways, and also we have seen some of the examples regarding to that. So in today's session, we are going to see some of the important methods that are used in our multi-threading concept. So let us see the methods now. So in that, first one is how to set and get the name of a thread. So first concept we are going to see is setting and getting the name. Setting and getting the name of a thread. So already we know that for every thread we are having a name. So what is the default thread we are having? Default thread is main thread. Default thread is main thread. So by default it is going to be created. So whenever a program is going to be started, this main thread is going to execute every instruction in your program. So if you want to create a thread, already you know how to create a thread. We have seen the different type of methods how to create a thread in our previous session. So in three ways we can create our own threads. So after creating a thread, what will be the name of that child thread? That will be like thread underscore one, thread hyphen one, thread hyphen two, and so on. Based on the number of threads you are going to create, it will be dependent on that particular number of count. That means first thread is going to have what? First thread will have number as 1. Second thread will have thread 2. Next, third thread will have thread 3, and so on. Based on the number of threads we are going to create, the number is going to be given to particular thread. So now the concept is, I don't want to use the default names. This is what default name. I have not given any name to this thread. By default, the name is given as thread 1, thread 2, thread 3, based on the number of threads we are having. So now I want to set the name of a thread. So every thread in Python has its name, its own name here. So by default, we are having one thread. The name of that thread is main thread. So after that, if you are going to create your own thread, the name will be by default what? Thread 1. If you are going to create a second thread, its name is thread 2, and so on. So if you want to change the default names by your own names, if you want to keep your own names for the threads, we can go for the methods called, we can go for the concept of setting and getting the name for a thread. So what are those methods? Let us see now. So first one is getName. So if you want to see the name of a thread, we have to use this method called as getName. If you want to set your own name, then we have to, or customized name, we have to go for a method called as setName. So whatever the name you want to pass, that means whatever the name you want to set for a thread, that has to be passed as a parameter for this setName method. So now I will show you one program where we are going to get the name of a thread and set the name of a thread. So one more point I have to discuss about this get name. That is, every thread has implicit variable. By default, every thread will have implicit variable. By default, one variable will be there for every thread. Okay, the name of that variable is name. Okay, name is a variable that will be available for every thread. Okay, so what this name is containing, it is going to contain name of a thread. So by using the concept of get name, or by using the variable called as name, we can get the name of a thread. So I will show you the example. So how to get the name by using a get name method, and also by using the name variable. So I will take a small example now. So already we know that from which module I have to take everything for multi-threading, threading module. So I want to import all from that module. So that I'm going to write import star. So here, just I don't want to go in depth about this. Just I want to talk about only current thread here. So for seeing the current thread, what is the method we have used? Current underscore thread is a function. Current thread. Okay, so now I want to see what is that current thread. For that I have to use what? Get name. The name of method is what? Get name. So now just I will save this one and I will execute this one so that you can see what is the output of this program. So here, what is that? Current thread. Current underscore thread means what? By default, what is the thread that is available in our Python? Main thread. So if that means this current thread is going to return. Okay, this current thread is going to return thread object. So to see the name of that thread object, we have to use getName. So now I will execute now. So you can see the output of this program. Okay, what will be the output of this program? We are going to get it as a main thread. Okay, 1 minute. Here we are having some problem with our shell. So I will go to our command prompt. Right. Anyway. Okay. Now see, I am going to execute that program. Right. So here we are having some getName. Sorry, getName is having capital N. Here I have written small n. Sorry. Right. So anyway, it is working. So we got what? Main thread. So answer is what? Main thread. Who has given this name? Who has created this thread now? Am I created in my program? I have not created that thread. By default, one thread is there. That is what? Main thread. That means here in this statement, what is the current thread we are having? Main thread. That means the statement is executed by a thread called as main thread. So here you have seen the name. So same statement I will write once again here. By using what I have to write? By using name variable I want to write. So just I will take name variable. Let us see what will be the output of this program. So see here, we are going to get both as main thread. One is by using getName method, another one is by using name variable. So that what we have to, what can we say by seeing this example? If you want to get the name of a thread, we can use getName method or name variable. Okay, right. Now I want to change the name of the thread. So I want to change the name of the thread. What is the name of the thread we are having here? The name of the thread is main thread we are having, as it is going to show you. I want to change this name. I want to change this name as what? Some other name. Let us take, so that what I have to take? I want to set the name for that particular thread. So current underscore thread. So what I want to do, I want to current thread name I want to change. So set name. What I want to set, I can set any name. Just I'll set the name as Shiva thread. Okay, just I'll keep Shiva thread, or you can keep any name. There is no problem. Now if I execute this program, from this statement onwards, the name of the current thread will be what? Shiva thread. So whether it is correct or not, I will check here by copying this one. Okay, now observe here. I will save this one. Now what is the output? What will be the output of this program? That is print of current underscore thread dot name. Means here which thread is executing this statement? Main thread. So the output of this statement will be main thread. In next statement, who is executing this statement? Again main thread. So current underscore thread is nothing but main thread object is going to be returned here, and for that thread I am going to set the name or change the name by using a method called as setName. So I'm changing the current thread name as what? Shiva thread. What is the current thread here? Main thread. That means from this statement onwards, the name of the main thread will be what? Shiva thread. So if I want to see that, I can print by using a getName. So I will execute this program now. So you can see the output as what? Main thread and Shiva thread, because I have changed the name of a main thread. So in this way, if you want to change any thread, we can change it. There is no problem. Okay, right. So now let us go to next methods. This is what? These are two methods used to get and set the name of the thread. Next, I want to talk about thread identification number. So before going to see the example, I will go to show you, I will discuss about thread identity number. Okay, for every thread we are going to have some number, that is nothing but we will call it as an identification number. So for every thread internally, unique identification number is there for every thread. Okay, we can access this ID by using an implicit variable called as IDENT. So identification number. So for every, for example, if you go to a college, for every student, what we are going to have? Identity card. In the same way, for every thread, we are going to have what? Identity number. If you want to access that identity number, I can use a variable called as IDENT, so that we are going to get the identity number of that particular thread. So here I will create a small program and I want to check the identity of the thread. So just I will create 2 or 3 threads and I will check it. So first I will create one small function, define test. Here I want to see what I want to allocate this particular test method as a task for a thread. So just I will print it as what? Child thread. This is child thread task. For that I'm going to write child thread here. Okay, right. After that I want to create the thread. Okay, just I have created only one statement. So t equal to create thread, what is the first method? Thread. In brackets, what we have to write? Target equal to, I have to write the function name which has to be executed by our thread. So I am going to write test, T-E-S-T. Okay. Now observe carefully here. Now after creating, what I have to do to execute that particular task, I have to use start method, T dot start. Here what we have to know, I want to know the identity of that particular thread. So for that I have to write what? I have to use IDENT variable. So I'm going to print that number. So here current thread is what? What is the current thread that is executing these 3 statements? Main thread. I want to see the identity number of your main thread also. So for that I'm going to use what? Current underscore thread. Okay, current underscore thread method I am going to use dot. So no need of seeing the name here. Just I want to find the identity number. So IDENT. Okay. So this is the identity number of whom? Main thread. Main thread. Okay. Right. Here I am going to get the identity number of a main thread. Now I want to see the identity number of a child thread also. That is this thread. So same thing I will do here. Just what is the reference for that particular thread? T. So T dot IDENT. This is what? Child thread. So just I will write here child thread. So child thread I am going to write. So what I am finding here? I am finding identities of a threads. This is current thread. This is T. Current thread is nothing but what? Main thread, because these statements are going to be executed by main thread only. So main thread dot identity number. So T dot identity is nothing but what? Already thread is created here. So after creating a thread only, we have to ask about identity number. After executing start only, we have to ask about identity number. So now what will be the output of this program? The output of this program will be child thread will be printed and the identities of main thread and child thread is going to be printed. So if you observe this, you will get what? Identity numbers of child thread and main thread. That is what? Main thread identity is 8404 and child thread is what? 8904. Otherwise, just for this test, I am going to write pass. Just I am going to write what? Pass. Now I will execute. So what is the identity of main thread? It will be changed regularly because internally many threads are going to be executed. So some threads going to be destroyed at the time of execute. Now I am going to execute my program. At this time, currently there are 10,000 threads, for example, in my computer. So now I have stopped the execution. Some threads may be dead. Again, when you are going to execute, some new threads may be created so that the number will be changed. If I am going to create once again, the number is C 82089480. Now if I execute once again, the number may be changed because internally threads will be created and those are going to be terminated. because internally there are many tasks to be done. Okay, I can't expect the exact identity number for a thread here. So if you are going to execute in your own computer, the output will be different. So anyway, based on your computer, the output is going to be generated here. Number of tasks that are going to be executed in your computer, based on that, this thread identity number is going to be assigned for every thread. Okay, right. This is about identity. To know the identity of any thread, I have to use a variable called as IDENT. Okay. Now here, how many threads are executing? How many threads are there here? T is one thread and current thread is main thread is one thread. Here current thread is nothing but main thread. So I want to find out at current how many threads are going to be run. That means how many threads are working. For that I am having a method called as, I am having one more method is there, that is active underscore count. There is a function called as active underscore count. This is a function which tells number of active threads currently running. So if let us consider some task is assigned for T, for example. So it is executing and T1 I am going to assign some task. Now these two are executing and main is there. For example, main thread is also running some task. So how many threads are there here currently executing? 3 threads are there. For example, T1 task is completed. Now I am asking how many active count, that means how many threads are running now? 2. No, answer should be 2. If the execution of this T also is completed, how many active threads are there? Only 1. So based on the number of threads that are going to be run, active count will be, the number of active count will be changed. Okay, now just I will change this program. Anyway, I can keep any name. Just I want to change it as some method name show. Okay. Now observe here, I want to print current thread name here. For example, print of. So to show you the name of that particular current thread, I want to use this one, current underscore thread. So it gives you what? Current underscore thread will gives you current executing thread dot get name. That means what? I can see the name of that particular thread. Right. Now we will get the name of the thread that is going to be executed. Now, okay, let us leave this as it is. After that, after execution of this particular statement by any thread, I want to give some time so that you can understand clearly. I will sleep. Sleep is present in where? In a time module. So time dot sleep. So when I am going to use some methods from your what can I say, module, I have to use that module here. So just I have to write what? Import time I have to write. So here what is doing? Just it is going to wait for 5 seconds. Main thread is waiting for 5 seconds. So the execution, I will write here, execution starts. I will write some execution starts. Print execution starts. Okay, it is working for 5 minutes. It is working for what? 5 minutes or 5 seconds, sorry. 5 seconds. After that, there is no task to execute. For example, I'm going to write print of, okay, execution ends. Okay, execution ends. So this is a small function I will call, sorry, I will make to execute by the threads. Now first I'm going to create a thread. So before going to that, I want to check how many threads are currently executing here. So print of what I have to write? Active count. I have to write what? Active count. So just I will write active underscore count I am going to write. So you can see what number of threads that are going to be available. How many are there? 2 are there. Okay. Don't worry about this count. I will explain clearly. Right. Now observe. So here Once again, I am going to here. How many threads are there? We should have only one thread. Okay. So which thread we have? We should have only main thread. We should have here. So anyway, I will after completing this one, I will show you clearly. So now I want to create some threads. I want to create some threads here. That is T1 thread I want to create. That is thread. Thread I am going to write here. After that, for thread I am going to pass target as what? Target equal to show. Okay, the task of T1 is to execute show method. Anyway, I will create same thing for T2 also. The task of T2 is also to execute same show method, show function. T3. How many threads I have created? 3 threads. One more thread I will create. So here T4 is there. Now 4 threads are there. Now I want to start all these threads. T1 dot start. Okay, and I will start all the threads. That is what? T1, T2, T3 and T4. So T2, sorry, T3, T2 and T1. So 4 threads I am going to start. After that, I will check number of active count. So just here I will write before creating threads. Before creating threads, count is active count is before creating a thread, active count is. Okay, anyway, we will get some answer here. How many threads? One thread is their main thread. Now after creating and starting the threads, I will see the count, active count. Print of after starting the threads. After starting the threads, the active count of threads is what? Number of threads that are going to be executed is, just I have to write same method, active underscore count I have to write. Right. Now observe here, I will wait for some time here, time dot sleep. So that what happens, some threads may complete its execution and again it will check. If again it checks what number of threads, how many it is going to execute, you can understand. How many are currently available, you can understand. So after sleeping, the active count is, after sleeping, active count is. Let us see this one. Let us see this program now. Observe carefully. See what happens. We got initially we got 2. Next one is what? Thread 2, thread 3, and so on. Anyway, one small spelling mistake is there. So I will change that one here. Right. Now observe here. So what we got? We got before creating threads, active count is 2. After that, we got what? We got thread 1, thread 2, thread 3, thread 4. We got. After starting the threads, the active count is what? So as it is going to see here you can find 6 active threads are there. So once again I will remove here, because here I have written something here. Just I will remove all these things. I will write just pass. Okay. Now I will execute. So see here, before starting active count. Okay. That is what before creating any threads, we got what? We got active count as 2. After creating number of threads, how many are there? We are having number of threads that are created. Again we got 2. Again we got 2. Why here always we got 2 means here I am not going to do anything. Just I will sleep here so that it will give you some different value. So sleep of 5. So just I will take here time dot sleep and okay, time dot sleep I have taken. Now observe here. So active count is what? active count will be 6 because I have created 4 threads and by default we are having 2. Okay. So see, what is the answer? First, by default we are having what? 2 threads. And after that I have created 4 threads. Okay. So that the count is what? The count is 6. After that, the task of all the 4 threads is completed. And we are having only 2 threads remaining. Okay. So this is about why here we are having 2 threads, means by default we are having one main thread and internally one more thread is there, so that we are having total count as 2. By default we initially will have 2. One is main thread which is going to execute our program. Another one will be there that runs internally. Okay. So this is about active count, so that we can understand what is the use of this active count. Active count is going to give you number of threads that are going to be executed currently. That is okay, currently I can say current active threads it is going to give. Okay, right. So initially by default it will be 2. One is main thread and one is internally one thread will be there. This is about active count. Now I want to go to next method, that is isAlive method. Okay, or before that let us see about let us go to enumerate function. So what is the use of this enumerate function? Enumerate, this is a function. What it is going to do means it is going to return a list of all active threads, so that are currently running, okay. Now you can understand clearly, that are currently running. Or I can say what, it is going to give you every detail of it, information about the thread that are going to be executed currently. Now you got here some confusion that why we got 2 threads initially. Now you will get the clarity, so that I have not explained about that particular why we got 2. So now you can see that one now. So what I have to use here, I have to use, before creating threads, I don't want count here. That is what, information about threads. Information of threads I am going to write here. So it will give me what, information about threads. What I have to write? Enumerate. What is the name of the method? Enumerate function. Enumerate function I have to write here. Okay, right. After that, after starting threads, the information of threads is, okay. Finally, after sleeping also, here I have written some active account. It is nothing but active threads. Okay, anyway, or active count, not active account. And now I'm going to write what? Information of, after sleeping, information of threads. So here what method I have to use? Enumerate. Okay, enumerate. Same here also I will use enumerate. Right, now observe here, if I execute this one, you will get clear information about the threads. So observe now, main thread, observe carefully, main thread, we got it. After that, 1 minute. Okay, after main thread we got some other thread, that is sock thread. Okay, it is also internal thread, daemon thread. It is also what? Daemon thread. So what is meant by daemon thread? We will see. One is main thread. For supporting this main thread, internally one more thread is going to execute. That is what? One daemon thread. After that, your own threads you are having. That is what? Your main thread and internal one thread is there. That is daemon thread. So next is what? Thread is there. Sorry, your threads. These are thread 1, thread 2, thread 3, thread 4. What is this 9572? This is nothing but what? Identity numbers. Okay. After sleeping threads, what we got? Only remaining 2 threads are there. So what we have to observe, by default we will get 2 threads. So okay, 2 threads you are going to get. So those two threads are by default available. One is what? Main thread. Another one is some Daemon thread is available. That is name is what? Thread only. The name of that one is thread only. By this you can understand clearly. Okay, right. This is the information about the thread. It will be in the form of what? List. So list it is the number of threads that are the type of list. The number of threads that are going to be returned in the list form. Okay, information will be in list form. So here also we got what? List only. Number of type of threads that are going to be printed are in list form only. In list only they are going to be printed. Right. This is about the concept of enumerate. So once again I am repeating the concept of active count and enumerate. What is the use of active count? Active count will give you what? It will give you the count of currently executing threads count. Okay, threads count. So by default we'll have two threads. One is, we know that for executing our program we are having one thread called as main thread and one more thread called as thread, which is going to be available internally. That is what background it is going to execute for our program. So these are called as what? Default threads. So initially count will be what? Active count will be 2. Okay, after that if you are going to create any other threads, let us create I will create 4 threads and I will start. If I start them, those are going to execute something. So if they are running, the count will be present. If they are stopped, let us consider here for each and every thread, it is some task is there to execute. For example, thread 1 complete its task. So what will be the active count here? These 2 are by default and only 3 are remaining. So when I am printing, sorry, that is when I am printing active underscore thread here, active underscore thread, sorry, active underscore count. If I'm printing active underscore count, why before I print here, before I'm using this function, 4 are executing. But when I am executing this function, this thread is completed. Then how many threads are there? Only 3 and plus 2. Total how many are there? 5 are active. So because one task is completed, so it will be dead. So automatically after completing the thread's execution, it will be terminated or it will enter into a dead state. This point you have to understand. So after completing the task of every thread, the thread will enter into a dead state. That is nothing but thread is going to be terminated. So now I talked about thread is going to be terminated. Now I want to check whether the thread is executing or not. Okay. Now what I told here, active count is nothing but number of threads that are going to be executing. That means that is actively running in our program. So what is meant by running? If those are running, those are alive. If I check alive of here thread 2, for example, alive of thread 2, I am going to, for example. So what happens? It is going to give me that it is alive or not. If it is alive, otherwise here t1 dot I will write t1 dot alive. If it is alive, it is going to give you what? Generally it will say answer as true or false only. So true is alive, sorry, it is not alive, is alive. If I am asking t1 is alive, that is like what? It will, I am asking question to it. Is t1 is alive? Yes. If it is alive, it will give you what? True. If it is not alive, it is going to give you false. Okay. So here I told you what? We may not know internally whether it is running or not. So to check that whether it is alive or not, I have to use a method called as, this is a method called as what? Is alive. So just I will write here a small program. So after this, or here I will write, observe carefully, here I will write 6, and just here I will ask whether it is alive or not. What I will ask? t1 dot alive, I will ask. Just only you see that one, I will remove all these cases. Just this one also I will remove. Right. Just here, what you can observe? You can observe whether t1 is alive or not. I am checking here. Observe carefully. here I got some attribute error. That is what, sorry, here not alive, it is alive. Is alive. So what is the output we got? We will get the answer as true. But here what happens? Oh, the method name is underscore alive, not is alive. Sorry. Anyway, we got answer as what? True here. Okay. So T1 thread object has no attribute is alive. I think it is alive only. Okay. Anyway, I think there is no underscore as it is correct only. So here what we are going to get answer as? We are going to get answer as true. Observe this carefully. We are going to get answer as what? True. Why we are getting this warning? It is only warning. It is not an error. Because we are having one more method called as is alive. We can also use that one also. Let us check that one. Is underscore alive. So see now. So we got what? True. So we are having two things. One is what? Is alive. So is alive is what? First I have executed what? Is alive. Is alive is what? Deprecated method. Anyway, it is there, but it is deprecated. So we should not use deprecated methods generally. So is alive is there. And also we are having what? Is alive. So better don't use this one. Use this one now. Both it is going to tell you what? It is going to tell you whether that particular thread is alive or not. In the same way, this one is also telling what? Whether the thread is alive or not. So, but it is a deprecated method, so it is not recommended to use. So it is not a deprecated method, so we have to use. Deprecated is nothing but what? This is not going to be used. It is what happens there, it has some problem, so that they have created one more method called as is alive. Deprecated means అణిచివేయబడింది. In Telugu we can say it as అణిచివేయబడినది. Okay, right. This is about what? Is alive or not. Let us consider after some time. I will say here I will sleep for 2 more seconds. After 2 more seconds, I will check whether T1 is alive or not. So why here T1 is alive means? So T1 goes here and sleeps for 6 seconds. So here your main is sleeping for only 5 seconds. So 1 more second it is alive only. T1 is alive only here. But here what happens? Let us see. After sleeping for 2 more seconds, I am going to check whether the T1 is alive or not. So automatically T1 is not alive. So we are going to get what? We are going to get false. False as an answer. First time it is going to give you what? True. Second time it is going to give you what? False. So see here, true we got. Sorry, I have tried. It is not time dot sleep. I have tried here, not T1 dot sleep. Time dot sleep. Right. Now observe carefully. It is sleeping. Why it takes some times to get the output means it is sleeping sometime. So now first I got true. After that false. Because at that particular time T1 is not alive. T1 is dead. Okay. So is alive, or we can go for a method called as is underscore alive. So use only is underscore alive. Don't go for the deprecated methods like is alive. Okay, just I have shown you we can use the both the methods. One is what? Is alive, another one is underscore alive, to get the information about that particular thread, whether it is available or not. Okay, right. Now let us go to one important method, that is join method. In previous session I have shown you about that join method. Okay, once again I will discuss in detail here. So in previous session I have shown you only just join. I have written in the example and I have directly executed the program. But now I want to discuss about this join method. Okay. So join is a method. So just I will give you one small example for this one. So T1 is there, T2 is there, T3 is there. Now in some situations what happens means, until dependencies, some dependencies will be there here. You know, already I have discussed when I'm discussing about basics of multi-threading. There is a chance of having some dependencies. That is, if T2 want to execute, it has to execute only if T1 completes its task, for example. So what it has to tell? It has to tell that I will execute only after T1 completes. If I write this one, The meaning of this one is what? T2 is telling that I will not execute until T1 completes. If T3 is telling I will not execute until T2 is complete. The meaning of this one is what? T3 is telling that I will not complete until T2 is completed. So for this, I will take a better example, real-time example, so that you will get a clear idea on this join, so that we can go to examples. So first one is what? Generally, the task of T1. I am take three tasks, T1, three threads. That is what? T1, T2, and T3. The task of this T1 is venue fixing for marriage. Okay, venue fixing. So the task of this T2 is, that is what, after venue fixing, wedding card printing. Okay, that is what? Wedding card printing. So after wedding card printing, what I have to do? I have to distribute wedding cards. Distribute wedding cards. Okay, here what we have to understand? Wedding cards here. Okay, anyway, when T3 has to execute, when distribution of cards has to be done? After wedding card printing, after venue fixing. So when this wedding card has to be printed? After venue fixing. Here there is a dependency is there. So T2 has to be executed only after T1 is completed. When T3 has to execute, T3 has to execute only after T2 is completed. So without what we can say, wedding card printing, can I distribute the cards? No, it's not possible. So without venue fixing, can I distribute the wedding cards? No. So that T2 has to tell what? T1 dot join. That means T2 is telling that until T1 is executed, I will not execute. That means what? So venue fixing is completed, so that now it can execute. T2 can execute. So it can distribute it can give the cards for printing. What T3 has to tell? T3 has to tell that T2 dot join. That means T3 is telling what? T3 is telling that I will not execute until T2 is going to complete. So T2 task is what? Wedding card printing. So after wedding card only we have to do what? Distributing the wedding cards. Okay. So I think by this example you can understand what is the use of this particular method. Okay, sorry, particular method called as join method. So now just I'm going to write same example in our program as a program. So what I have to do? I have to create a three threads. First method is what? Venue fixing. Venue fixing. Okay. After that, I will write one more method called as define venue fixing here. After that, card printing. Card printing I am going to write. Okay. After this, okay, definitions I will write later. Define, I will write one more method called as after card printing, distribute. Okay, right. These are the three methods are there. So in this, just I will write when print of distribute venue is fixing or venue is fixed. Venue is fixed. So after this one only, where I have to go? I have to go to card printing. So card printing has to wait for what? It has to wait for one more thread to execute. One more thread to execute. So here I can write what? Current here current thread will be what? Whatever the thread I am going to that is going to execute this card printing will be current thread. So current thread dot, what it has to do? It has to join, apply join. Okay, sorry, on what it has to execute apply join? It has to apply join on T1 and T2. So did here we know T1 and T2, we don't know here. So what I have to do here? Just better I will show you by taking only two threads. Just I will take only two threads. That is one is main thread and one is tail thread I will take. Otherwise you will get some confusion. First I will take a small example only. So here I am going to write what? Just I will take the method as show method only. So show method I will take. Here I am going to write some for loop I will write, so that we'll get more time to execute this. We can observe clearly whether it is executing or not. For I in range of 10, I want or 5, I want to print some message 5 times. So I will print what? This is child thread, I will print. Otherwise, child thread, I will print here. So child thread. So child thread is going to be printed 5 times. For every printing, it has to wait for 2 seconds. So sleep for 2 seconds. Okay, it's sleeping for 2 seconds. What's the target here? Show only. Now observe carefully. Now here I am going to start this thread. T is going to be started. So here T1 is there. T1 is going to start. That means the task of T1 is what? Show method. So it will execute this one. At that time, whatever main thread has to do, it will execute remaining statements. Those remaining statements are for I in range of 5, I am going to write here. Okay. Otherwise, here what I will write here, just I will write venue fixing. Here I will write venue fixing. Okay. Here what I will write? Here I will write printing cards. Okay, printing cards. And now observe carefully. If I execute this one, what will be the output? Sometimes it will give you venue fixing, sometimes it will give you printing cards. Here also, okay. So let us see the output. Without this, I will take the output. Okay. Now see the output. It will be mixed. I cannot say venue fixing and printing cards is going to generate it. So output may be varied. I can't expect the exact output because venue fixing E is missed there. Anyway, don't worry. So see what happens here. It is giving venue and printing cards only every time, because we can't say it will give you every time same, because in yesterday's session I have shown you different examples. 4 or 5 times I have executed. See now it is changed. I can't expect the exact output because both are executing simultaneously. But what is my task? What is my task? Otherwise, just I will remove this one for your sake, and I will show you what. Just I will take only one statement. So first, which statement has to be executed? First, venue fixing has to be done. So until venue fixing, your thread, another thread has to wait. So just what I will say here, T1 dot join. So who is telling T1 dot join? Which thread is executing here? Here main thread is executing all these statements. So main thread is telling that I will not execute until T1 is completed. The meaning of this T1 dot join is nothing but main thread is telling I will not complete until T1 is completed. What is the T1 task to execute? Show. That means first this one will be printed. Now next printing cards is going to be printed. It is compulsory. So observe here. First venue fixing and printing cards. If you execute n number of times, there is no problem. Every time it will give you same output. So to see that output clearly, what I will do means just I will write here for loop. So for every time, if I write 10 times also, there is no problem. The output will be same. The output will be same. Here I will execute 10 times and I will show you nearly 10 times I'll execute. Same output will be generated because here in sequence dependency is there. After executing T1 only, main thread is telling what it will execute. So compulsory after executing T1 only, your main thread is going to execute. Here I am going to write 2, for example, range of 2. So here I will write what? Time dot sleep also I will write. So we can see the output clearly. Time dot sleep of 2 I am going to write. Here also I will write 2 only because it will take some time to print. So print of time dot sleep of 2. Okay. Now observe carefully. You can see the correct output here. So as for loop is there, I have to write what? I have to give indentation. So observe now. So what happens when you fixing? So it will give you what? After when you fixing only, we will get printing card. So it is correct. Completed. Now, if I remove this T dot join, observe carefully. Can you expect the output? We will not expect. We cannot expect the output. So see, when you fixing printing cards, completed. Again, if I execute same program, I can't expect output. Anyway, it is giving same output. If I execute 4 or 5 times, it may change. Okay. Anyway, it's showing now as it is. If I increase the I will write here join. If I write join, what can I expect output or not? I can expect output here because first main thread is executing here. and main thread is telling what? I will not execute. That means this for loop is not going to be executed until T1 is completed. That is the concept. Now observe. So when you fix after that only printing cards. It is compulsory. Okay, right. Now the case is, sir, how much time? Let us consider if your child thread is executing for so much time, large time, this join method has to wait, compulsory. But I don't want to wait for such a time. So that if you don't want to wait for long time, you can take some time here. I will wait only for 3 seconds. If you complete before 3 seconds, okay, I will wait. Otherwise, I will not wait. Now observe. So it will, if it is completed, if child thread is going to be completed within 3 seconds, okay, no problem. I will wait up till 3 seconds. If you are not going to be completed within 3 seconds, I will execute my task. Let us see. So see what happens when you fixing, it is waiting, no problem. Printing cards. Now what I will show you is, here I will take, observe carefully, 5 times. Now you can observe clearly. Here I will take 5 times. Now listen carefully. And here, okay, first I will execute this program. So see, no problem here also. When you fixing, printing card, see why it is going to change. In between. The reason is, you are telling what your join method is telling. I will wait only for 3 seconds. 3 seconds means what? First time it waits for 2 seconds. Second time, after 1 second is completed, it will execute this one only. This particular statements are going to be executed. If I write here 15, that is what this will be executed. How many time? 5 iterations it is going to done. That means minimum 10 seconds. Sorry, I require here, but I am writing what? 15. So there is no problem now. So every time what it is going to print? When you fixing 5 times it will print. There is no problem here. When you fixing. After when you fixing, it is going to print what? Printing cards. Reason is what? So the main thread is going to execute its task. When it is going to execute its task after 15 seconds. Within 15 seconds, if it is completed, no problem. If it is not completed, child thread will execute this one and main thread starts execution. Let us take here 10. Now what happens? 5 times it is going to iterate. I will take 8. Here. So 4 times it will execute. After 4 times, it starts also execution. Main thread also will start execution. So as child thread is not completed, the output will be mixed. First 4 times there will be no problem. So when you fixing. Now up to here I can guarantee. After that I cannot guarantee here. See. Printing cards, when you fixing, I can't expect, because until that I can say that your child main thread is waiting. After that main thread is not waiting, because I have given some time there. That is what? 8 seconds. It will wait only for 8 seconds. Okay, then it starts its execution. This is about join. So these are the very important methods of your multi-threading. So one more concept is there, that is Daemon threads. This is also very important concept. Let us see that one now. So what is meant by a Daemon thread? First, I will explain about Daemon threads. Next, I will show you some examples regarding to that Daemon thread. Right, observe carefully here. What is the name of our concept now? Daemon thread. Very easy concept. Right. Now, what is meant by Daemon thread means the threads which are running in background. Threads that are running in background. Threads running in background. Is called as what? Daemon threads. Daemon threads are called as Daemon threads. What is meant by background? So if you see this program, whatever the program we have seen here, how many threads are running in foreground? One is main thread, another one is T1. That is thread 1 is going to execute. 2 threads are executing here. So internally, background, we cannot see those threads. Those threads are going to execute. So those, if the threads are going to be executed background, I can call them as what? Daemon threads. Is T1 is Daemon thread? No, because it's executing in foreground. Is main thread is Daemon thread? No. It is executing what? In foreground only it is executing. So it is called as what? It is called as non-Daemon thread. The threads which are executing background are called as Daemon thread. The threads which are executing in foreground, those are called as non-Daemon threads. So what is the main purpose of this Daemon Threads is? The main objective of this Daemon Thread is to provide support for non-Daemon threads. Non-Daemon threads. Okay, right. That means, so let us take one small example. If I am going to consider a student, if he is studying, if student is going to college, and if he is studying, so how he can study? Some background, someone is going to support him. Those are nothing but parents are going to give support to the student. So that student got first rank, for example, first rank. So what he will say, for example, he is going to write IIT JEE, he has written one exam. So in that he got what? First rank. What he will say, in my back my parents are there, because of them only I got this rank. That means what? These are called as background threads. So why these are there? Why these parents are available here? To support this student, to support only. For example, so because of Daemon thread support only, he is working. He got first rank. Let us consider one student is there, he is not having any money because parents are not there for him. Because, and if parents are not there, he is not having any money, for example. Can he study? No. That means what? Here, without Daemon threads, this particular threads cannot work. The main task of Daemon thread is what? Sorry, opposite I have to tell. That is what? If there is no foreground thread, there is no task for Daemon threads. What is the main task of Daemon threads? The main task of Daemon threads is to support foreground threads. The main task of parents is what? To support students or their son or daughter. Okay. So without foreground thread, there is no need of having this Daemon threads. Foreground threads, if there is a foreground thread, compulsory for giving support to that foreground thread, we can have some Daemon threads. But if you are not having any foreground thread, is there any need of Daemon threads? No. Okay. The main objective of Daemon thread is what? To provide support for non-Daemon threads. Can we take an example for non-Daemon threads? Tell me one non-Daemon thread. Non-Daemon thread is what? Main thread. Because main thread is what? Main thread is executing in foreground. Okay, in my program only. Okay, right. So, okay, as I said you about Daemon, non-Daemon, I want to tell about Daemon thread also. So one of the Daemon thread I can say is what? Garbage collector. Already I have discussed this concept. Garbage collector. Garbage collector works where? In background. To whom it is going to work? So whenever there is a, let us consider, some memory is there for our Python. So I have created many objects here. I have created many objects in my memory, so that now there is no space in my memory. There is no space in my memory to create a new objects. So internally our Python will do what? Python will call this garbage collector. So garbage collector will come here internally, background. So and will clean what? If there is any object that is not referred by any of the references, those are going to be removed. That means what? The space that is allocated for that objects are going to be cleaned. Cleaned by whom? Garbage collector. So that what happens? This memory is going to be available for the new objects. See, internally it is going to support. This garbage collector is going to give support for whom? For whom it is going to work? For foreground threads. Foreground threads are doing what? Those are creating objects. Okay. So whenever main thread runs, see here, whenever main thread runs with low memory, that means if main thread is executing and internally there is no memory, then what happens? Internally your Python virtual machine will be there, or Python interpreter I can say your Python interpreter is going to do what? It is going to call garbage collector, or it is going to run garbage collector. So that what garbage collector will do? Garbage collector is going to destroy whatever the objects that are not going to be referred by any of the references. Okay, so that main thread can continue its execution, because as these are free now, so main thread can create some more objects and it can execute its task. Okay, right. Now here you may get some doubt that, sir, how we can find whether the thread is daemon or not. Is there any possibility? Yes, we are having a possibility to find out whether the thread is daemon thread or not. Okay, so for that we are having one method called as isDaemon. Okay, that method name is what? isDaemon. For example, so one thread is there. I want to check whether this thread is daemon or not. I have to use what? isDaemon method. Okay, and next, so I am having what? Two types of threads are there. One is daemon thread. Okay, another one is non-daemon thread. So non-daemon thread want, okay, non-daemon thread want to become a daemon thread. Non-daemon thread want to become a daemon thread. For that also we are having some method called as setDaemon. setDaemon of true. If you write setDaemon of true, then automatically that particular thread is also converted to daemon thread. So just I will show you an example so that you will get clarity on this one. Okay. So before going to see, once again briefly I will tell, because this is a new concept for you. So background threads are called as what? Background threads are called as daemon threads. Okay, daemon threads. Foreground threads are called as non-daemon threads. Okay, so these are what? Daemon threads, and these are non-daemon threads. For example, here I can take what? By default we are having one non-daemon thread. Sorry, this is a this is daemon thread. So that I can give you example for daemon thread as garbage collector. So garbage collector is going to execute for whom? For the foreground threads only. For the main thread only, it is going to execute generally. So I can take what? Garbage collector is one of the daemon thread. Next, for example of this foreground thread, I can take it as a main thread. Okay, right. So what is the use of these daemon threads? Generally, why we are going to create the daemon threads? The main purpose of this daemon thread is to give the support for non-daemon threads. That is the only purpose for the daemon threads. Let us consider, if there is no non-daemon threads are there in your program, then what is the need of daemon threads? The purpose, if there is a daemon thread, what is the purpose of that daemon thread? To give the service for the non-daemon thread only. But if there is no non-daemon thread, then automatically there is no need of daemon threads. Okay, right. Now I will create a small example. Right. Now here, just I want to create one thread and I want to check whether that thread is daemon or not. So first I want to print current thread. What is the current thread here? Main. I want to check the whether it is daemon or not. So by default it is running here. Where it is running? Foreground only. Okay. Dot is daemon. Is it daemon or not? No, it is not daemon, because it is non-daemon thread. What is the current thread here? Main thread. Is main thread is daemon? No, false. Answer is what? False. That means your current thread, which is nothing but a main thread, is not a daemon thread. Okay, now, and also we are having one variable to check this one. That variable name is daemon. Daemon. So like our name, for this one more variable is there for our threads. That is what? Daemon. One variable is called as what? Daemon. If I write this one also, we are going to get answer as same. Okay, let us see. So see, false, false. That means what? To check whether the given thread is daemon thread or not, we can use what? isDaemon method, or we can also use daemon variable of a thread. Next, I want to set a thread as a daemon thread. Okay, as here you have seen what? As you have seen here, a thread is what? Whatever the thread we have created is what here? Whatever the by default, that thread name is what? Main thread. So here, if you want to change the nature of a daemon thread, that means what? If you want to change the nature of non-daemon thread or any thread, then I have to go for the concept of what? setDaemon. We can change the daemon nature. The daemon nature is nothing but what? If it is non-daemon, I can make it as a daemon by using which method? setDaemon. But very, very important point I have to discuss here, that is when we have to apply this set daemon means before starting of a thread, before starting of a thread, before starting of a thread, only we have to apply which method? Set daemon. Set daemon we have to apply. If we are going to apply after starting, then what we are going to get? We are going to get an error. Once it is starting, we can say what? If it is starting, I cannot change the nature of that one. If you are not going to start, I will change the nature and I will start it. So remember this point. If the thread is started execution, I cannot change the daemon nature. If the thread is not started execution, I can change the nature. Just I will show you that one. So here what happens? Here by default, one more point I have to, by default, which method, thread is created? Main thread. Who is executing this one? Main thread only. That means what? Main thread is started execution. So can I change the nature of a main thread? I cannot change. So if a thread is going to be if already a thread is started, I cannot change the nature of that particular thread. So here, can I say main thread is started or not? Yes, main thread is started because who is executing the statement? Main thread only. That means main thread is already started. Can I change the nature of that thread? No. So compulsory, I can say one point that we cannot change the nature of main thread. Okay, or we can say default thread, because it's already started execution. If it is not started, I can do it. So now I want to change the nature of that one. Let us see whether I can change or not. Current underscore thread dot set daemon. Set daemon as true I have to write here. Okay, true I have to write. Now observe carefully. Can I do it? Is it possible? It is not possible. See, cannot set daemon status of active thread. If it is in active mode, I cannot change the state. If it is in not active mode, what can I do? I can change the nature of that one. So I will take one more example here. So just I am going to write T1. So I want to write one more method here. Define show I am going to write, and just I will write pass. That means no body I am going to give to this one. T1 equal to thread I am going to write. That means what? This is a thread. So I want to write some what is that? Target equal to show I am going to write. Now observe carefully. Did I started this one? Did I start the thread? No, I have not started. If I want to start the thread, I have to apply what? T dot start. I have not written that statement. So before writing that statement, what I will write? Print of, here what I will write? Nature, daemon nature. I have to write daemon nature is, sorry, of T1 is, what I have to write? I have to write T1 dot, I have to check first. T1 dot is daemon, and checking is it daemon or not. No, it is not a daemon. So you may confuse that, sir. How you can say by seeing that is it daemon or not? 1 minute, spelling mistake. Right. Now observe here, what it is saying? False. Is it daemon? No. How it got the nature of daemon, that is a non-daemon? Reason is, who is creating this T1? Main thread. So what is the nature of a main thread? Non-daemon. So automatically from the main thread, what are the properties that are available for the main thread, that are available for this T1 also, because it is created by whom? Main thread. So T1 is also having which nature? Non-daemon nature. So we have understood that T1 is having non-daemon nature. Now I want to change the nature of that one. So T1 dot, because I have not started till now, T1 dot set daemon. I am changing nature of what? I am setting the nature of, I am changing the nature of T1. Is it possible? Yes, it is possible. There is no problem. After changing it, I want to check now. I want to check. So see, daemon nature after setting, after setting. So sorry, here I have used what is Daemon. What I have tried here, setDaemon. setDaemon I have tried. Okay, anyway. So now what is the answer here? Main thread dot is Daemon. No. So answer is false. So here one thread I have created and I'm checking what is Daemon or not. Is it Daemon or not? It is not a daemon because it is created by a thread. As thread is a non-daemon thread, the children also will get the same property, so that here false. But now what I am doing, t1 dot set daemon, I am setting t1 as daemon thread. If I check here, it will give you true. Observe carefully. So what happens? First false, next false, but last statement what happens? True. That means here I am changing the nature of that particular thread. Sorry, here I am changing the nature of that particular thread. Let us consider before going to change the nature. If I start, what happens? Automatically you are going to get an error. See, cannot set daemon status of active thread. Why it is saying active thread? Because t1 is started here. If I comment this one, what happens? You are going to get correct output. That is true. You are going to get what? True. Right. So here what we have to understand here, how the how T1 becomes non-daemon, because main thread is creating that child thread. So that what by default this particular main thread is of which type? Non-daemon type. So it is creating the child thread. So child thread also will get the same properties, okay, which is inherited from the main, right? So by default the nature of main method is what? Non-daemon, so that whatever the child it is going to create, it will have the same properties. So one point we have to understand, can we change the nature of your main thread? It is not possible because it is already started. So let us consider here, who is executing the statement? Main thread. That means our main thread is started. Who is executing the statement? Main thread. Main thread is started. So if I want to change this nature of the what we can say, nature of main thread, is it possible? It is not possible. Okay, right? Main thread is always non-daemon and we cannot change its daemon nature because it is already started at beginning only, so that we cannot change it. We have to observe this point. So whenever, observe carefully here, whenever the last non-daemon thread terminates, automatically all threads will be terminated. Already this point was discussed. What is the need of daemon thread? Tell me. So if there is a daemon thread, why we are having daemon thread? To support non-daemon thread. I am telling what? All the tasks of non-daemon is completed. Then is there any need of daemon threads? No. So these are also will be destroyed. For this, I will take one small example so that you can observe that whether non-daemon threads are present or removed, that is deleted. So observe carefully. Just I will take a small example. Here I will take in this I will take one for loop. So for loop I am going to take for I in range of 5. I am going to write here. Next, just I want to print what? Child thread. Print of, I will want to write what? Child thread. I want to write child thread. Right. Now here I want to create a thread, and after child thread I will take some time. That is time dot sleep. I am going to write of 2, or I will take some time 3 seconds. Otherwise 2 seconds I will take. So where time is from, where sleep method is from, import time. Right. Now observe, just I will create one. I don't want this one. So t1 equal to t1 equal to thread of target equal to show. Now I want to start that thread t1 dot start. After starting, just I want to sleep some more time. T1 dot time dot sleep of 5 I am going to take, or I will take some 3 only. Here also 4 I will take. Right. Now observe here. Here I don't require this one also. Just I will write here end. Just I will write what? End I will write here. Now observe this program once. Here I am not using any concept. Child thread, it will print child thread. So we are getting some error. Cannot set daemon status of active thread. So where I am trying to set it? Here, because T1 is running. It is weighted up to here because it is sleeping here. So once T1 is running, see, once again I will explain here. So whenever T1 not start, it goes here. So it is waiting for about 4 seconds. Up to 4 seconds, it will not giving you any error. But after 4 seconds, what is it telling? It is telling that child thread is what? Running now. So that I cannot change the nature. Just it is giving that exception and it is executing. So see, it's giving that exception and it's going to execute that task. This is very important. You have to understand. Okay. So the concept here we have to understand is what? If here what happens? Here there is a setting T1 dot set Daemon as true. If I am trying to set the nature, if I am trying to change the nature of a thread, compulsory that thread should not be started. Okay, right. Now here I will include one more point here. That is, I have written okay, T1 dot set Daemon I have written. If I am not going to write this statement, I will show you. Okay, observe carefully. Will there be any error here? There will be no error. Child thread will be printed, and after that, end of the main is going to be printed. Okay, end is printed in between because the two are simultaneously executed after sleeping some time. Okay, so this is about the concept of Daemon threads. So here few points we have to understand. Those are what? First point is, what is the use of Daemon thread? Daemon threads are for which purpose? Daemon threads are background threads. First point you have to understand, Daemon threads are background threads. Right. What is the use of these background threads? To support foreground threads. To support what? Foreground threads. Next. Yes, it is supporting foreground threads. So can I, if I want to check whether the thread is daemon or not, I am having a method called as isDaemon. isDaemon. Okay. So okay, it will tell me what? Whether it is daemon or not. Right. If I want to set some thread as a daemon, I have to use what? Sorry. Set daemon I have to write. Set daemon of true I have to write. Then only the nature of that particular thread is going to be changed to daemon. Now, compulsory when I am going to set some thread as daemon, it should not start. Thread should not start. If it is started, we cannot change it. Thread should not start. Next, can we change the nature of main thread? Main thread nature cannot be changed. Main thread nature cannot be changed because what is the nature of the main thread? It is foreground. Okay, cannot be changed. It cannot be changed into daemon thread. As it is a non-daemon thread, it cannot be changed the nature to daemon thread. Reason is what? It is already started running here because starting statement is going to be executed by whom? Main thread only. Okay, so main thread nature cannot be changed. Next, by default, all child threads will get daemon nature of parents. That is nothing but what? If I am going to consider main thread is executing and main thread creates a child thread called as T1. Whatever the nature it is having, it will be given to T1. Okay. So this is the concept of daemon threads. These are the important points we have to understand. When these daemon threads are going to be destroyed, once all foreground threads are going to be executed, automatically your daemon threads are going to be destroyed by default. Okay, whenever last daemon thread terminates, automatically what happens? All daemon threads will be terminated. Okay, so in next session we are going to see the concept of synchronization. Thank you.